Welcome to Swift versus C, episode 3, where we experiment with C and Swift programming languages and try to compare them. So I have a small update from the last episode. I tried to run this very simple program. Let me just print it out here. Very simple hello world program. I tried to compile it and run it on other systems, so not on a Browser API, but as well on M1 system and on Intel Mac system. And my findings are more or less the same in terms of well, actually not really the same. So compiling is like 50% slower for Swift. Let's actually try this here. Maybe we'll have to run it multiple times just to get it to the operative memory. Okay, so it's around 0.1, and then if we compile C, it's lower. It's like 10%, maybe a little bit more lower. So compiling C is faster still, and this is M1 system, so it's quite a fast system, and it's native system for Swift. So I think the comparison is fair, because on Browser API we don't understand what we're really running there, and also it is the latest supported version both of C and Swift. And if we time execution, this is Swift. Well, it's kind of instant really when it is inside operative memory. And if we try C again after it is in operative memory, it's kind of instant, and it is the same time. So compiling is a little bit faster for C, but execution is kind of the same time. Also was comparing file size, and actually they are very similar here, but C is still a little smaller. So if we look into bytes, we can see that a.out file is a little bit smaller, and hello file, which is a Swift file, is a little bit bigger. But actually I was wondering about this difference, because before on Browser API I can switch to it here. I was getting like 7 kilobytes executable, and then here on M1 I have 49 kilobytes. And I was wondering why. Then I checked compiler, and actually Apple uses here CLang, and if we look inside Browser API we can see that it is actually GCC. Yes, it is GCC, and it's quite an old version actually. So I was thinking maybe it is because of this, but then I installed GCC on M1, and actually the file size is the same for GCC, at least more or less the same. So it's something else. I'm not sure what it is. Probably it is some settings, some customizing for compiler, but I'm not sure actually. So going forward, I think it's more fair to use a native platform for Swift for the comparisons. We can also look from time to time to Browser API if you want, but I think mainly I want to focus on M1 platform. And by the way, on Intel platform it is the same, foundings are the same. I think compiling is a little bit more slower, like not 15% but around 20 to 30% slower, but findings are exactly the same as we have on M1. Why did I even start comparing? Because yeah, here if we try to execute a Swift application, it takes 0.009, and if we go to and check the same for C application, I think it should be slower. A.out, right? Yeah, it's much sorry, it's actually faster. It's much faster. So this is where I was confused, and I thought that comparison might be not completely fair, but we will try to compare them in here in M1, and we will try to compare them using the more intensive applications as well. And this actually brings me to the actual episode 3. So I wanted to write a simple program. This program is for conversion conversion of temperature. Let's call it Celsius to Fahrenheit, and that's C. Okay. So first of all, let's include our input output. I don't have syntax highlighting here. Do I have? Maybe it's like okay, now it works. Okay, again, include standard input output for C, and then we have a main function. And in this function I will convert some temperatures from Celsius to Fahrenheit, and I don't want to introduce any input at first. I will just use, I don't know, some constant temperatures, like from 0 to 100, and the step for me will be 20. Okay, so we need to introduce some variables. I will introduce our constants here. We call it lower, upper, and step, and this will be integers. And I will also introduce temperatures, and I will use floats for temperatures. Okay, float, and I will call it Fahrenheit and Celsius. Actually, Celsius, this is the correct way to write it. Okay. Okay, then I will assign a value to our constants. Lower will be 0, of course. Upper will be, as I said before, 100, and then step will be 20. Okay, and then we will need to well, let's first assign a value of our Celsius. Celsius equal lower means 0, and then we will create a while loop, and while loop will run until Celsius is actually less than or equal to upper. Okay, and then we need to calculate our Fahrenheit temperature, and we will do it like this. So we need to multiply our Celsius by 5, I believe, actually 5.0, because it is a float. Then we divide it by no, actually we multiplied, sorry, we multiplied by 9, and then we divide by 5, and then we add 32. Yeah, I believe it should be correct. We actually do not care too much if it's correct or not. Then we will print our temperature, and in C, when we use printf function, we can actually embed the values inside the function, inside the string, and we do it with special operators. So we use a percentage sign, and I believe we use F for float, and then we give a space, for example, and we use another F, percentage F for another float, and then using comma we give our values. So we convert from Celsius, oh, actually there is a mistake here, convert from Celsius to Fahrenheit. Okay, that's it. And then we need to add step value to our Celsius variable. Step. Okay, and I think that's it. This loop should work. I hope so. Let's test it. So if we compile it, cells. Actually, let's rename it. Move. I made 2 mistakes here in the name. Okay, now let's compile it. Okay, it compiles without errors, and here's our output. Of course, I forgot, as usual, to end the line. Let's do it, but otherwise I think it looks fine. Let's first fix the line here. Okay, compile and execute. Okay, here's our values. So some things we would want to do is well, we don't need so many zeros after dot, and actually I don't think we need any zeros at all in this case. But yeah, to make it like more general, I will have some zeros, but I think I want to have only 1 0. It should be fine to have only 1. And let me edit the program again. And also I want to format the number. So there is a very good way to do it in C. You can provide this is the size of the number of the float, and then you can provide dot, and you can provide a size number of characters for a number after the dot. And we can do the same thing here. I believe it should be the same for me. And yeah, that's it, I think. Okay, and again we compile. And now I have them. Okay, why didn't it work? 3, or maybe 3 is total. So let's come back here. By the way, this is not educational content because I'm not an expert in this topic. Let's first compile and then run again. Okay. Yeah, so now we have these numbers like formatted the way I want it. Maybe last step, I want also to add a header. Where do I want? Maybe just before the the loop. So I want to print the header, and the header will be, I think I want it the same size, right? So let's give percentage 6 and then the string I think is S and space again 6S, and then I want to give strings. Actually this will be single characters. Let's try it. So first it's Celsius and then it is Fahrenheit. Okay. Actually, as usual, I forgot at the end of line. Okay. Let's compile it. Warnings. Yeah, so the format is wrong, but it's just a warning, so it should still work. But I think I want to fix it with this quotes. This is strange. Okay. Okay, now it should be fine. Here I have my header. Okay, now let's do the same thing in Swift. So let's create a new file. Okay, so we don't need to include input output, we don't need to introduce a main function, we just provide variables. In Swift actually we can introduce constants. We can explicitly say that this value will be never changed. I will not introduce lower, let's introduce upper as integer. Maybe let's actually introduce it as a float, because Swift will check, Swift will compare the values. When you compare the values, they should be the same type. So actually let's explicitly say that this is a float, otherwise it will be double type, and type double. So let's do it like this, then step again, let's put space here, float 20. Okay, and now let's introduce our variables. Variables will be introduced using var, and again we just assign the value. And oh, I forgot, this is also a float, so we don't have to separate. So in C we usually separate where we introduce our variables and where we actually assign the values. In Swift we don't do this, we usually do it at the same time. Okay. sorry, float, and as well 0, and then we write the cycle. We also will use while cycle, the same one we used in C, and let's say while cells is less than equal to upper, Fahrenheit equals Celsius multiplied by 9 and divided by 5 and plus 32. Okay. Then we need to print. Okay, and here's the tricky part. I'm sure. I'm pretty sure that command print doesn't have like formatting built in, and there is no printf function in Swift, so we will use something like this. We will use a string function, and we will initialize a string with a format. We'll provide a format. In a similar way, we did it in C. So this is our format, and then we provide a value. This is our value, and then we will add a space, and then we will add another string. Okay. Fahrenheit. Okay. Okay, I think it should work. And then we add, and we can use addition operator. We add our step. Okay, looks good. The only thing I believe we're missing here is printing of header. So I don't know if we can actually print the same way we did it for C, because this formatting thing I showed before, it works only on numbers. So I will use just spaces 1, 2, 3, 4, 5, and then 6, and then F. I believe that's it. Okay. I hope it is it compiles. So let's try. I made a typo. Let's try again. Okay. Why didn't it work? The card expects me to provide another argument, but I don't want to do it really. Okay, yeah, let me check something real quick. I'm not sure why isn't it working. Can convert value of type float to expected argument integer. So it wants us to add repeating parameter. This is strange. Okay, let's do it. I think repeating one. How should I write it? Repeating one, like this. Okay, formatting is not working in Swift. I'm not sure why. It should work. I tested it before, it should work, but it doesn't work. So we cannot do it, at least within standard. Okay, let's do it. Let's do it by just introducing it like this. We can have embedded parameters in Swift, and inside we provide a backslash, and then in parentheses parameter, then space to separate, then again backslash and parameter, and this should be it. Okay, let's try to run it. Okay, it works, but without formatting. I'm not sure why formatting doesn't work. So, yeah, we get the we gave Swift like a head start in terms of that formatting. We don't have formatting in Swift, and then with it, let's still compare. What do we have here? So Swift executable is 2 kilobytes more than C executable, even with all this formatting missing. Okay, let's time compiling of cc and cells.c. Okay, so first one usually more, so I tend to ignore it. So okay, 8, 9, 8, 7. Okay, and then let's time compiling for Swift. We can see that it is 2 times more. But the compiling, I think it's fine, because yeah, it's a type-safe language. There are a lot of checks during compiling, so I think it is fine. But yeah, file size, I don't like that it is more. Let's also time execution. Let's start with C actually. Okay, almost instant. 0.006. What about Swift? Okay, also almost instant, but a little bit slower, just a tiny bit slower. Okay, yeah, I think that's it for this episode. Yeah, that's it. So see you later.